Hello everyone, welcome back to mathematics. Before I start the lecture, I just want to say I'm really sorry for the inconvenience. Recently I have very bad allergy and now I have a runny nose and an itchy throat. Every time the season is changing, so that's the reason why. I'm allergic to the temperature changing, so be patient with me, okay? Okay, so in this video we're gonna talk more about function. In previous lecture we already discussed what function is. We talk about all the characteristic of function. Today we're gonna go further into function. We investigate function in another way, and this concept it helps you to derive a more complicated function from the basic one, from the parents function, and it helps you sketch and grab the complicated function based on the basic function based on the parents function. The concept I'm talking about we call it transformation. Okay, so let's get started. So I'm gonna put a topic here, transformation. Okay. Transformation. Okay. So the reason we call it transformation because we transform a basic function to a more complicated one. The name will tell you everything, right? Transform. The form is changed to get a new function. That's what I mean. And there are several ways of transform the function. The first method of transform the function we call that vertical shifting. Vertical shifting. So the first one is vertical shifting. Okay, it means that we transform we're shifting the function vertically. Okay, based on the basic one. Okay. Okay, given the function like this, given function f of x, so we can derive a new function, but g of x by shifting f of x vertically, mean going up or down by the c value. If you add the original function to the c value, then it means it's going up, it's shifting upward. So plus it means shifting upward. and minus mean shifting downward. Okay, now let me give you one of the basic function we already learned in the previous section. What if I have a quadratic function? What if I have something like this? Okay, let's sketch the coordinate system. Again, the transformation concept, it just helps you to sketch. I mean, if you want to be more accurate, you have to plug in a point. Okay? Sketching is not enough. So I have the basic function, quadratic function, something like this, huh? So I have f of x. So this is f of x. Okay. Now, what if I want to shift? I want to shift f of x upward 2 units. So this is 1, this is 2. So I'm going to shift it upward 2 units. So I'm going to have something like this, right? Because I'm shifting upward 2 units. So this is 2. So this is the function, I'm going to call the function g of x by equal to f of x plus 2 plus 2. Or I can shift downward. I can shift downward 2 units. So my new function will be something like this, huh? There you go. So I'm gonna call this function. Let me call that g star. Okay, g arters. Just the name. Okay, just the name. It doesn't mean anything. The star over here doesn't mean anything. It's just the name. By subtract 2 from f of x. So you see that I can get the new function. Okay, I can get a new function based on the parent function. This is a quadratic function right here. This is a square root function with the vertex at 0. Okay. All right. So that's the new, the first type of transformation. The second type of transformation is called horizontal shifting. Horizontal shifting. So the goal of the lecture today is it help you to recognize the transformation. So at the end, I'm going to give you some function. It's a very complicated one, and I want you to recognize the transformation. You're gonna state all the transformation you can see in that function. Okay. But before we able to do that, we have to know all the transformation first. So the second one we call horizontal shifting, and instead of the new function, oops, I'm sorry. The new function can be obtained by subtract the argument by c unit. Okay, so the g function can be obtained by subtract or add the argument by c unit. So you see the difference? You see the difference is that this is add and subtract c unit from original function outside the argument, but this one inside the argument. Okay, but another difference is that if it plus c, we moving leftward. So most of the time you will see that plus is moving right, but actually it's moving left, and minus is moving rightward. Alright. Now let me give you a very simple function. I have something like this. I have I don't know if you guys can recognize this function. So I have something like that. What kind of function is it? Anyone can recognize it? Okay. This is an absolute function, huh? So this is f of x. This is f of x, and we can move to the right 2 unit. Okay, moving to the right 2 unit. Okay, something like that. Okay, moving to the right 2 unit by subtract the f of x. Subtract the x, subtract 2 from x, I'm sorry, inside the argument, and you can move to the left 2 unit. Okay, so you see that I use different colors so that you can see which one. Okay, this is, I'm going to call it g star function, and I subtract the argument x. I add the argument x inside the function. Okay, so you can see that the difference. It's inside, and this is outside. And you can apply this transformation to all different type of function, not just the basic one. You can get a very complicated one from a complicated one by applying the transformation too. Okay. Number three. Okay. The new type of transformation is the reflection. So reflection, and we have two different type of reflection. There's a reflection about the x, so reflection, and reflection about the y, about x-axis. Given the function f of x, and we can obtain g of x by putting the negative in front of f of x. Okay, so if you put the negative in front of the original function, we can mirror the graph of f of x over the x-axis. Now let me give you an example of something like this. If I have a function like this, okay, it's y(x), and I'm gonna give you the sketch like this. Anyone who can recognize this function? This is what is that? This is square root function, huh? This is like this is square root function, and I can obtain the new function g of x by mirroring the f of x over the x-axis. So I'm gonna mirror them. There you go. This is g of x by put negative in the front of f of x. Okay, so that's the reflection about the x-axis. And we call the second type of reflection is reflection about y-axis. So the difference is, instead of putting negative in front of the function, we're going to put the negative in front of the argument x. Okay, if we put a negative in front of the argument x, then we can reflect over the y-axis. What if I have something like this? Okay, let me give you the... Oops, I don't know why I keep clicking that. So I have the function like this. Okay, and again I'm gonna give you another one. Okay, let me give you this one. I don't know if anyone can recognize this. This is a cube root function. This is a cube root function. This is square root. This is square root. Okay, this is absolute. Okay, the very basic one. And this is quadratic. Square root. Oh, this is a square function, not square root. This is square root. This is cube root. Now I'm gonna reflect this. I'm gonna reflect this one over the y-axis. So this is gonna become something like that. There you go. There you go. So this is my new function, g of x, the cube root of negative y. So you see that I put the negative inside the function, not in the front. Okay. Alright, so there are 3 of them already. Now the fourth type of transformation is the vertical stretching and compressing. Okay, vertical stretching and compression. Okay, so how are we gonna obtain that? Okay, again, given the function of x, we can obtain the new function g of x by multiply a c value in the front of f of x. But if the c value is, there will be 2 different cases. It depends on the c value. Sometimes we have stretching, sometimes we have compression. If the c value is greater than 1, then we can stretch the function, stretching the function vertically by multiply the y coordinate by multiplying y coordinate by multiply y coordinate by the c value, by c. And if c is between 0 and 1, we can compressing vertically by multiplying y coordinate. Well, it makes sense, right? We had to multiply the y coordinate because this is a vertical by c value. So c in this case is a fraction between, because this is between 0 and 1, and between 0 and 1, so the fraction, the numerator must be smaller than the denominator. Now I'm gonna give you something like this. What if I have let me give you the absolute function, okay? That one you can see that easily. So I have the absolute function, the basic one, something like that. Okay. This is f of x equal to absolute of x. Now I'm gonna multiply the c value. In this case is the c is greater than 1, then it could be stretched vertically. So now what is going to be stretched like? It could be longer. It's elongated along the y-axis. Okay, it's elongated along the y-axis. Then my new function here is g of x. G of x is c f of x, but c in this case is c greater than 1. Okay, c is greater than 1, and we can compress horizontally. Okay, we can compress horizontally. Okay, by multiplying the c value. So this is g star function. Multiply c by f of x, but c in this case is between 0 and 1. So you see that it compressed down. So this is opening wider. So this is opening wider. It is elongated. This is elongated, and this is opening. It's opening wider. Okay, it's opening wider. All right. Okay. So that is the Well, I can give you another example with number with the point so that you can see it. What if I have something like this? I don't know why I keep clicking this. What if I have the graph like this, and let's say this is 1 2 3 4, this is 1 2 3 4, -4, so this is -2. So I have the point right over here. This is my original one, okay, and over here I have -2. Right over here I have another point. So I have this one. So I have like that. So this is my fx function, and over here I have 2 and 2. Point right here. Okay. So this is my fx function, and this, you see that this a satisfied vertical line test. So this is a function. Now, what if I want to transform this? So I want to transform. What if I want to transform this by stretching vertically? Okay, stretching vertically. Okay. Then I want. What if I transform by the factor of 2? What if I want to multiply fx by 2? Okay, and 2 is greater than 1, so it means that I multiply the y component. The y component in this case is will become 8, right? Become 8. Now multiply the y component. This is the -2 and 4. Huh? So multiply the y component. So they multiply by 2. So it will become 8. This is. I'm sorry. I need to extend this. So become 8. So 1 2 3 1 2 3 4 4 8 right here. Okay. Become 8. Multiply the y component by 2. Okay. So they become 8. So my new one will be this. Will be -2 and 8, right? And we multiply by 2, so we become multiply by 2 will become -4, right? -4. So this is -4. So they become, the new one will be this one, right? The new one will be this one, and -4, -4. Instead of -4, -2, so we have -4, -4, and this is 2, right? So 2 2, so we become 2 4. Multiply the y component by 2, but the x component you had to keep. Okay, so my new function will be something like this. Okay. My new function will be something like that. So you see that it's longer, right? A little bit longer. There you go. So this is my new function. This is, I'm going to call it g of x by multiply f of x with 2. There you go. Okay. So this elongated along the y-axis, huh? Okay. Now the large transformation. I can do the same if you want to do compression. Let's do compression also. But if I want to compress by the factor of 2, by factor of 1/2. Okay. So it means that I multiply the y component by 1/2. So instead of here we're gonna have 2 and multiply by 1/2. So this 2 to become a half, right? So it'll be here. So instead of 4 to become a half, so it would be 2. And instead of -2 it become a half, so it become negative 1. There you go. So my new function will be something like this. There you go. So this is my g star function. Is 1/2 f of x. Okay. All right. That is now the last transformation will be horizontal stretching and compressing. Okay. Last time it's vertical, now it's horizontal. Kind of the same thing. Kind of. So we have the function, and we can obtain a new function, but instead of multiplying the c value in the front, we multiply it inside the argument. C value inside x. And there will be also two different cases. If c is greater than 1, if c is greater than 1, for example like 2, then what? If c is greater than 1, then will be compressing. So instead of stretching last time, this is compressing horizontally by dividing the x component, x coordinate, by c value. Okay, so this compressing, and if it lie between 0 and 1, then this stretching horizontally so by dividing the x coordinate by c value, and c over here must be a fraction, right? We got it between 0 and 1. Now let me give you something like this. Let me give you compressing. Let me give you the one with the points, so that you can see easier. Okay, what if I have this? Okay. Let me see. Yeah, let me give you something like this. It's kind of same thing. So what if I have a quadratic? Let's do quadratic again. Or maybe we should do square root 1. Or maybe let's do something simpler. I mean, square root is kind of hard to plug in a value. We can, but I mean, let's do something simpler so that you can see it. Let's something like last time. Okay. So what if I have 4? This is -2, and this is -4. And over here I have -2. Over here I have 2 and 2. So I have 3, 1. Kind of the same as last time. 3, 1. So they have f of x. Okay. Oops. So I have apox here. Now, what if I want to compress horizontally? So I'm gonna by factor of 2, so 2 greater than 1. So I'm divide the x component. So I divide the x component by 2. So 2 divided by 2 will be 1. So my new one will be, I keep this, it will be 1, 1, 1, 2. Will be the negative 1, 4. The x component, okay, so it will be negative 1, 4. And 2, the x component here will be negative 4, so it will be this. Negative 4 divided by 2, negative 2, so it will be this. So my new function will be in this. Okay, so this is my gx function. Will be f function by multiply the argument by 2. Now, what if I want to do stretching horizontally? So I by 2 by the factor of 2. So by factor of c squared and c by factor of 1 over 2. Okay, so I divide the x component by 1 over 2. So I will have the x component by 1 over 2. So it will be 2 divided by 1 over 2 will be 4, right? So it will be 2 and 4. So it will be 4. So it will be 2 and 4. So it will be right here. Here. So it will be negative 4. So instead of negative 2, 4, then we have negative 4, 4. Because we divide by 1 over 2, we mean we multiply by 2. So instead of negative 4, negative 2, so we have negative 8. Because we have negative 8. So it will be right here. Negative 8 and negative 2. So we have this. There you go. You see that it's stretching horizontally. So we're gonna have something like that, and we're gonna have something like this. There you go. Then this is my new function. G star of x will be f, but you multiply by a half. All right. So you see that it is stretching, right, horizontally. And you go back and look at this. It's not the same. I mean, it's not the same. You think it is the same, but it's not, right? It's not. It's just stretching horizontally and compressing horizontally. Okay. Now, on the first exercise, I'm gonna give you a pretty complicated function that was derived from the basic function. I don't want you to state all the transformation of that function. Okay, so let's do the first one together. So example number 1. I'm gonna use this color right here. Example number 1. Given. So I give you the function g of x. So this one is already been transformed. Okay, it's negative 1 over 2 x minus 2 square plus 3. On the first question, I want you to state the parents function. I mean, state the function f of x. And number 2, I want you to state all transformation. Okay. So let's see how we do this. So first of all, we need to know what the g function derived from. So you see this is a square thing. So this is a square thing. It means that the function f of x, that which is the gx come from, must be the square function. So fx must be x squared. This color is not good, right? I think I'm not gonna use this one. It's just so let me use this one. Okay, so fx must be x squared. Now on the second one, we want to recognize the transformation. So you see that x squared, and you subtract, you add 3 to that. So you mean shifting upward 3 unit. Shifting rightward 2 unit, because it's minus. Okay, we have the minus in the front, so we have reflection about x-axis. Then 1/2 in the front, 1/2 in the front. So if you look at this one right here, 1/2 in the front, right over here, 1/2 between 0 and 1. So to compress vertically, okay, compress vertically. So I'm going to put vertical compression. By a factor of 1/2. Okay, by a factor of 2. Anything else? Yep. So there's only 4 transformations over here. Example 2. Given. Negative square root negative x plus 2. Okay, so we're gonna do the same thing, same answer, same question. So we have the original function must be the square root function, so this must be this. I can recognize the reflection about x-axis, because the minus. We have there's no vertical shifting, but we have horizontal shifting. But you have to be careful right over here, because there's a minus in the front. So last time we don't have a minus, so this minus right over here, we move into the right. So in order to know this is moving left or right, we gotta set this equal to 0, and you solve for the x. Okay, so x equal 2. So x is equal to it's x equal 2 over here. So you see that if you set this equal to 0, you see this also x equal 2, right? It is positive. Okay, so we know that this is shifting right. Okay, so it's also shifting to the right 2 unit. Okay, but the minus in the front right over here, the minus in the front over here tell you that this is also reflection. Okay, reflection about y-axis. Okay, there you go. So that's all. This one. It's, the next one a little bit harder. 3. function like this. G of x will be -3 absolute 2x plus 1 minus 1. Okay, so same thing, try to recognize the parent function. The parent function is easy to see, which is absolute of x, but we have vertical shifting downward 1 unit, right? We have horizontal shifting, but we don't know is left or right. If it is positive, we right. If it negative, is left. So we gotta solve for this. So we have 2x equal -1, x equal -half. So it's horizontal shifting to the left, 1/2 unit. We have reflection about x-axis, right? Because this negative right here. We have compression. No, we have no, it's not compression. We have vertical stretching, because number 3 right here, vertical stretching by the factor of 3. And we have number 2 over here. So number 2 over here, if you go back and you look at that, you see that number 2 inside, right? So the compression horizontally, so horizontal compression. Okay, we have horizontal compression by a factor of 2 right here. Okay, here you go. I think that's it. Okay, that's a very simple example. Now in the next example, I'm going to give you one problem, and I want you to do it yourself. Okay, as the practicing problem. I have something like this. G of x equal to -1/3x plus 4 minus 1. Alright, first question, state parents function. Then B, step O transformation. Alright, so go ahead and try to practice this problem yourself. Okay, let me know if you have any trouble. Same thing, example number 5. Let me review the function. I have something like this. 2. Okay. -4x minus 2 plus 3. Alright, same question. Okay, same question. Alright, so only 2 problems for you to practice. Okay, so I'm gonna stop the lecture over here. If you have any question, please send me a message, or you can see me in my office. Okay, I'll be seeing you next time for the new lecture. Bye bye.